This section is on special triangles. Special triangles have degree measures of 45, 45, and 90, or 30, 60, and 90. In this section, you will use the relationships between the legs and hypotenuses of special triangles to find the lengths of unknown sides. You will also learn how to solve more complicated problems by applying the rules for special triangles more than once. Special triangles are right triangles. One angle measure will always be 90 degrees. If you know you have a special triangle, either a 45, 45, 90 triangle or a 30, 60, 90 triangle, and you are given the length of one side, you can find the lengths of the other two sides of the triangle. This differs from most right triangles because with most right triangles you will need to know the lengths of two sides in order to find the third side. The 45, 45, 90 triangle is a right triangle with two equal legs. The hypotenuse is the square root of 2 times as long as the leg. If the leg has length x, the hypotenuse has the length the square root of 2 times x. If you are given a hypotenuse, divide that length by the square root of 2 to find the leg. There are two common situations in which 45, 45, 90 triangles occur. The first is in a square, because the diagonal of a square divides it into two isosceles right triangles, which of course are 45, 45, and 90. A second way of recognizing a 45, 45, 90 triangle occurs with triangles that are drawn into a circle with one of the angles at the center of the circle. And if you're given a circle with a center at A, the triangle ABC is isosceles because its sides AC and AB are congruent radii of the same circle. That means that angle B and angle C will also be congruent. If one base angle is 45, the other base angle must also equal 45, thus the other angle must be 90 degrees. Similarly, if you are told that the vertex angle, which in this diagram is at A, is 90 degrees, the other two base angles, B and C, must be 45. In example 1, find the hypotenuse of a 45, 45, 90 triangle when given the leg. In this example, we're given the 45, 45, 90 triangle with a leg of 1. If you don't know the relationship, you can substitute into the Pythagorean Theorem, where both A and B are equal legs, and we can replace A and B with 1. A squared plus B squared equals C squared. 1 squared plus 1 squared equals C squared. This gives us 2 equals C squared. Taking the square root of both sides gives us the square root of 2 equals C. This ratio holds for any 45, 45, 90 triangle. The hypotenuse is always the square root of 2 times longer than the leg. A triangle with a leg of 5 has a hypotenuse of 5 square root of 2. In example 2, a 45, 45, 90 triangle has a hypotenuse of 10. Find the length of the leg. Again, just so you can see how we derive these ideas, we're substituting into the Pythagorean Theorem, and since the legs are equal, we're going to call both A and B x. Substituting gives us x squared plus x squared equals the hypotenuse squared, which is 10 squared. Doing the arithmetic gives us 2x squared equals 100. Dividing by 2 gives us x squared equals 50. Therefore, x equals the square root of 50. We want to simplify that radical term, the square root of 50, as much as we can. The square root of 50 can be factored into the square root of 25 times the square root of 2. The square root of 25 is 5, therefore that leg is 5 square root of 2. The faster way to find the leg when given the hypotenuse is to divide the hypotenuse by the square root of 2. We rationalize the denominator by multiplying both numerator and denominator by the square root of 2. When we do that, that does become 5 square root of 2. Here are some practice problems for you to work. Pause the video after each problem. When you're done, come back for the answer. Practice problems 1 and 2 are presented on the same slide because they involve the same sort of formulas and reasoning. And the practice problems are: a square has a diagonal of 1. What is the length of each side? And 2, what is the area of the square? The length of the side is the square root of 2 over 2. And the fastest way to find the side length is to divide the hypotenuse by the square root of 2. Remember, the hypotenuse, which is that diagonal, is 1. We divide by the square root of 2 and rationalize the denominator, and we get square root of 2 over 2. The area of the square is 1 over 2. Recall from part 1 that each side length is the square root of 2 over 2. To find the area of the square, we multiply that by itself, so we have the square root of 2 over 2 times the square root of 2 over 2, which is 2 over 4, which reduces to 1/2. Practice problem 3. If the hypotenuse of a 45, 45, 90 triangle is 5, what is the length of the legs? The answer is 5 square root of 2 over 2. We divided the hypotenuse 5 by the square root of 2 and rationalized the denominator to get that answer. Here are practice problems 4 and 5. You are given a square, and what you're doing is you are analyzing the figure to find the side lengths of the square. Then you're asked to find the length of the diagonal and to find the area of triangle ABC. The answer to question 4 is 4 square root of 2. The diagram tells us that the side lengths of the square are 4. Therefore, the hypotenuse must be 4 square root of 2. In question 5, the answer is 8. Each leg of the right triangle is 4 units in length. In a right triangle, the 2 legs are the base and the height. Therefore, A equals 1/2 base times height equals 1/2 times 4, which is 1/2 of 16, which is 8. In problem 6, you are told to find the area of the triangle. Note that the base angle is 45 and the radius is 2. The area of the triangle is 2. The area of a triangle is 1/2 base times height, and that's 1/2 times 2, which is 2. Next, we want to look at 30, 60, 90 triangles. And these side lengths have a ratio as well. The side length of the shorter side, which is opposite the 30-degree angle, is x. Then the hypotenuse is twice as long, which is 2x. The longer of the 2 legs, which is opposite the 60-degree angle, is the square root of 3 times x. In words, the hypotenuse is twice as long as the shorter leg. The longer leg is the square root of 3 times as long as the shorter leg. When given the longer leg, divide by the square root of 3 to find the shorter leg. Then multiply the value of the shorter leg by 2 to find the hypotenuse. In example 1, if the diagonal of a rectangle equals 20 and makes a 30-degree angle, find the area of the rectangle. We know that triangle ABD is a 30, 60, 90 triangle. If BD equals 20, then the shorter leg AB is half of that, which is 10. and the longer leg is 10 square root of 3. The area of the rectangle is 10 times 10 squared of 3, which is 100 times the square root of 3. Now we're doing some practice problems on 30, 60, 90 triangles. When you are done with each problem, come back for the answer. Practice problems 1 and 2 are using the same figure. It says, given the figure below, find the length of AD and find the area of the rectangle. Recall that you have a 30-degree angle and that side AB equals 2.5 inches. The answers to practice problems 1 and 2 are as follows. For problem 1, the answer is 2.5 square root of 3. The area of the rectangle is 6.25 times the square root of 3. The length and width of the rectangle are 2.5 and 2.5 square root of 3. Multiplying the length and width together gives 6.25 times the square root of 3. Practice problem 3. Find the length of AD in the figure below. Note that the figure is not drawn to scale. Note that segment CD equals 4, segment BC equals 5, and angle A equals 30 degrees. The answer to practice problem 3 is 3 square root of 3. Recall the diagram. Look at triangle CBD. By the Pythagorean Theorem, BD is 3. BD is also the shorter leg of triangle BAD, which is a 30, 60, 90 triangle. Thus, the longer leg AD is 3 square root of 3. Here's practice problem 4. What is the length of DB in the figure below? Recall the figure. The answer is 7.5. The trick is recognizing that you have 3 30, 60, 90 triangles. ABC, the overall larger triangle, is one of them. If AC equals 5, then AB equals 10 because it's a hypotenuse and twice as long as AC. AD is the shorter leg of triangle ACD. Therefore, since its hypotenuse is 5, the shorter leg is 2.5. BD is AB minus AD, which is 10 minus 2.5, which equals 7.5.